Welding Codes Overview, Module 1F, or at least a slice of it. These slides a bulk of them are from the Nuclear Regulatory Commission Introduction to Welding Technology and Codes course. My name's Gary Pace. I'm a PE and CWI. Just going to try and give you a little overview and insight into WPSs and PQRs. And for those that don't speak the language, that's a welding procedure specification, and a PQR is a procedure qualification record. I'm going to try and help you sift through the alphabet soup of those acronyms. So that's where we're going. Hopefully you'll get something out of this. Here's the acknowledgments. The information I'm going to use is out there in the public space. I just borrowed it from the U.S. government. It's our money at work anyway, so what the heck. But this is from the Nuclear Regulatory Commission Introduction to Welding Technology and Code course. You can see the website that you'd need to go to get it. Also, CanTeach is public domain educational and reference library on CANDU technology. It's a Canadian deuterium uranium. So like it says here, this is good information for people on a budget, and it's good info. But I took their slides and wheedled out a bunch of stuff and kind of compressed it down so it's not, 50 slides. Maybe we'll get it down to 20 some, and it'll be useful information to people trying to understand PQRs and WPSs and the alphabet soup that's associated with those. Before we get into this, we need to understand the terminology. WPS is a welding procedure specification. It's qualified instructions on how to complete the weld. It is a recipe card that you give to the welder that tells him how to make the weld. It is how you bake the chocolate chip cookies. How much chocolate chips are required, how much sugar, butter, salt, whatever, how long you cook it for. Those are all things that are written on the WPS. They are the instructions that tell the welder how to complete the weld. The PQR is a procedure qualification record. It's a record of welding parameters and test results. So that is the parameters and the test results that we used the first time we made chocolate chip cookies. The very first time. We put them in the oven for a certain amount of time. It is the recipe that we used. So it is going to be the backup documentation for the WPS. And then we've got a WPQ, which is a welder performance qualification. This is a record of welder test results and ranges of approval. We're not going to get into that today because that's a whole nother animal, but I just wanted to address it here and say that welder qualifications, they do exist, but they are not a part of a WPS and PQR. That's a whole different world. So realize that welder performance qualification paperwork and documentation does exist, but it does not influence the PQR and the WPS. ASME boiler and pressure vessel code sections. We're going to concern ourselves with ASME Section 9, but the slide that the NRC put together, it's got a couple other sections on here. Section 2, which covers materials, which is filler metal, ferrous and non-ferrous materials. Section 2 just tells you what is the chemical composition and the mechanical properties that are required to make a specific type of code material. Materials you're going to be utilizing to make boilers and pressure vessel components. Section 5 is non-destructive examination. That's the rule book you follow on where, how, what, why, when you're going to do non-destructive examination. Those 2 and 5 are both outside the scope of what we're going to talk about. We're going to talk about ASME Section 9, which is the document that covers welding and brazing qualifications for boiler and pressure vessels. Overview of ASME Section 9, welding and brazing qualifications. The primary purpose for procedure qualification is to verify the compatibility of materials and techniques to result in sound weld with acceptable properties. The WPS is the instruction to a welder, And the PQR is qualified by mechanical testing and is documentation of mechanical testing. So to qualify a welding procedure, the weld must be destructively tested. You can see I've spiced this slide up with a couple of pictures of, in the middle there's some Sharpie impacts. On the right there's some bend tests. And then on the far left you can see some tensile tests. So these are probably the three biggest, most common tests that you're going to run across when trying to qualify a weld procedure, depending on what you're doing, what the end use of the component is, what the construction codes call out that need to be done. But bottom line is a PQR is going to be destructively tested, and it's going to be documentation of the mechanical properties during that destructive testing. As you get into Section 9, you're going to have to understand Article 2, which is QW 200 and everything that's in there. You're not going to have to understand everything that's in there, but that's where the information that is required for a welding procedure qualification is covered. WPSs and PQRs are covered in Article 2. So QW 200 General describes what information belongs in a WPS and PQR. This is the rule book. Tells you exactly what you need to put in a WPS and a PQR. It also addresses changes to the WPS. So if you change a WPS, do you have to go back and requalify another PQR, or can you just run with it and update the WPS with a different revision? So it addresses changes can be made to non-essential variables without requalification. Non-essential variable would be something like filler metal size. So if I qualified the weld with 7018 and 332 filler material, well, I could then use 1/8 or a different size filler material because I'm using the same filler material, it's just a different size. So, but if I specify just one size on my WPS, one size filler metal, I have to follow that to the letter of the law. And if I want to add another size, then I need to update my WPS to say, okay, we can use 1/8, 332, 5/16, 1/4 inch filler material to weld this, to make this joint. Changes to essential variables or supplementary essential variables, when required, require requalification. An essential variable would be something like the shielding gas. If I was using a different shielding gas, let's say I qualified the weld with 100% argon. Let's say I'm using gas metal arc welding. Let's say I use 100% argon to qualify the weld. But then I want to change that, and you go to using a mixture of 100% or 75% argon and 25% CO2. Then I've got to requalify. I need another PQR that says, hey, we've gone through, we've used this gas mixture, we've gotten good mechanical results doing that. So hopefully that helps you out or addresses that. I'm trying to explain it without getting too deep into it. This is all the manufacturer and contractor's responsibility. And in Article 2, you can use oxy-fuel, shielded metal arc, submerged arc, gas metal arc, flux core, gas tungsten arc welding, PAW, electroslag welding, electro-gas welding, electron beam welding. There's a whole bunch of them. And then the type and number of tests required for procedure qualification are also listed in here. So this is the recipe book that's going to tell you how to qualify your PQR and your WPS. Once you get into Article 2, Welding Procedure Qualifications, you have QW 250, which is welding variables. So this lists the essential and non-essential and supplementary essential variables for each welding process in Section 9. So shielded metal arc welding is not going to have the same essential variables as submerged arc welding or plasma arc welding or gas tungsten arc welding. Essential variables are those in which a change is considered to affect the mechanical properties of the weldment and shall require requalification. Gas metal arc welding, you switch gases. You switch filler metals from, let's say, a carbon steel filler metal to a stainless steel filler metal. That would be switching, F numbers and A numbers. Non-essential variables, those in which a change may be made in the WPS without requalification. Like I said before, that would be something like changing the size of the filler metal. You're still using the same filler metal, it's just a different size. And maybe on your initial revision of the WPS, Rev 0, you said, okay, we're only going to use, 332 filler metal. That's it. Well, situation comes up and you want to use 1/8 or 532. You need to rewrite that WPS and include the new sizes of the filler metal to be utilized by the welder. But you don't need to requalify another PQR to support that. You're using the same stuff to weld it together, so you don't need to requalify it. You just need to update your WPS that says, yep, we're going to use these sizes. It's cool. The welders can use these. We're good with it. Supplementary essential variables. This is when notch toughness is required. Supplementary essential variables become essential variables at this point. So if you're doing something that requires notch toughness, then you have supplementary essential variables, and you treat them just like essential variables. These are things, I'm not even going to go into this. I don't have a list in front of me, but these are things like heat input can be one of them. How much thermal energy you're putting into the weld, things like that. So the procedure variables cover all aspects of the weld quality. But just realize that when you're writing your WPS and you're getting ready to do everything, put your PQR together, you need to go into Article 2, which has QW250, the welding variables. You find your specific welding process, and then you just go down the checklist and say, have I addressed this, 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 and this? Here you can see we have an overview of Section 9, Welding Qualifications. Here you have, remember in the previous slide I talked about QW250? Well, here we're at a little chart called QW255. This is the Welding Variable Procedure Specification, gas metal arc welding. These are the variables that you need to address when you're writing a WPS for either gas metal arc welding or flux core arc welding. ASME Section 9 considers gas metal arc welding and flux core arc welding to be the same process. Even though there's some variations and a couple of differences, they say close enough, it's the same thing. So you can see you've got 3 columns on that right side: essential, supplementary essential, and non-essential. So when you're writing a PQR, when you're going through and you're doing your PQR, you hit everything on the essential variables. All of those have to be addressed. Even if you're not doing them, you have to address them. If you're not using post-weld heat treat, put none. Don't address an essential variable with NA. Just put none or not used. Things like if you go down to QW 404, filler metals, and 404.24 is supplemental filler metals, you got to address it. That's one of the things you have to address. If you aren't using supplemental filler metal, put none. Don't put NA. The second column is supplementary essentials. That's for something that is when you're going to need impact testing. When impact testing is part of your project or your component, you have to address all those essential variables, and then they become essential variables. The supplementary essentials become essential when you are involved in a project where they need impact testing. Non-essential variables, those are all variables that need to be addressed, but they don't need to be addressed on the PQR. Non-essential variables need to be addressed on the WPS. You can address them on the PQR, but you don't have to. So when you write your final WPS, you're going to have all your essential and non-essential variables on your WPS, and your PQR is just going to have your essential variables. And if you're doing impact testing, you're going to have supplementary essentials on there. I hope I was able to explain this and not turn it into some kind of who's on first, what's on second type situation. Here's a partial list from QWQB 422. This is ferrous and non-ferrous P numbers and S numbers. This is a little older slide. I don't know if S numbers even exist anymore. But P numbers still exist. P number for ASME Section 9 is a grouping. You can see on P numbers there, we've got a bunch of 8s, some 3s, 4s, 3s, 4, 5, A, 1. What ASME P number is it separates things into categories. It separates base materials into categories of things that are close enough that you could count them the same when doing qualification. So like P8s are austenitic stainless steels. Unless you're for just a regular run-of-the-mill weld procedure qualification, you would go by the P number. There's group numbers too, which break it down into further categories, a little finer. But, so back to a P number 8. A P number 8 would be austenitic stainless steel. So if I qualify a weld procedure with 316 L stainless steel as the base material, I would get everything else in P8. So ASME does this to keep there from being just a zillion weld procedure qualifications that would be required. So they say, well, if you can weld 316 to 308 or 308 to 308, if you can weld a P8 to a P8, you get all P8 to P8. We're not going to make you qualify every single combination of filler metal or base metal that's in those P8s. So, or if I qualified P1, which is carbon steel, to P8, I go A36 to 316. I would get every combination of P1 to P8. Unless, there's always got to be that unless there's impact testing involved. And if impact testing involved, you got to go by the group number. So, if we're doing some kind of project where impact testing was required and I did P8 group 4 to P1 group 2, I would only get P4 group materials welded to P1 group 2 materials. So it just breaks it down a little further. The group number divides materials up into their ability to withstand impact. So that's where you're going with that. But it's the P number and group number system is set up so that you can, qualify, one procedure and you'll get a whole bunch of different other base metals. But they're close enough and they're in that family so you don't have to qualify a zillion different combinations of base metals. Okay, here's a slide that shows the overview of ASME Section 9 P numbers. So you got P numbers. So it gives you the P number in the description. P number 1 is carbon steels. They don't use P number 2 anymore because it was wrought iron. I had to ask a guy, what happened to P number 2? And he's like, oh, back in the day, back in the 40s and 50s, they used to have P number 2, wrought iron, the stuff that the Eiffel Tower is built out of. But we don't use that for making boilers and pressure vessels anymore, so they just got rid of it. So then you've got 3, 4, 5. These are alloy steels where you've thrown some other constituents in there to adjust the chemistry and give you different mechanical properties, maybe better creep resistance or better properties at higher temperatures. So that's where you get 3, 4, 5. 6 is martensitic stainless steel. P7 is ferritic stainless steels. P8 is austenitic stainless steels. Once again, if I qualify a weld with a coupon where I'm going from austenitic stainless steel to, P1 carbon steel, I would get all of those. I would get everything in the P8 and everything in the P1. unless, like I said, unless we're using a procedure that impact testing is required, and then it would go into the group numbers. But just for your garden variety WPS, P1 welded to P8 gets you everything in P1 welded to P8. So something to keep in mind while you're doing procedure qualification. Here's some more. We've got P9s, which are nickel alloys, nickel steel alloys. 10A and through 10K are duplex stainless steels and high nickel steels. 11A and 11B are low alloy quench and tempered steels. The 20s are aluminum and aluminum base alloys. 30s are copper alloys. 40s are nickel and nickel base alloys. 50s are titanium alloys. And 61, 62 is zirconium based alloys. So depending on what you got going on and what you're welding, you'll run across different items or different materials depending on, what the scope of your work is and what the component is you're manufacturing. But they've pretty much got a number marked out for most metals or families of metals that you would utilize in construction of boiler pressure vessel components. Not to say that there aren't some things that are outside of these groupings. You have unlisted materials. Let's say there's something that isn't listed in a particular family. You get some material that's carbon steel out of Lithuania or something. It's not listed as a P number, so you have to qualify the procedure as an unlisted to whatever you're welding it to. But I'm not going to go down that rabbit hole too much. I'm just letting you know that it exists and it can be done, but it's generally not pretty most of the time. The purpose of welding procedure specifications and procedure qualification records is to determine that the welding operation proposed for fabrication are capable of producing welds with. You can see here's a suggested format for welding procedure specifications. You don't have to follow this. You have to address all the essential and non-essential variables, but you don't have to follow this format. You can invent your own format if you want. Nothing says you have to follow the suggested format. They give you an idea. Yeah, this is one that works for a lot of people. You want to use it, run with it. If not, invent your own. I worked at a couple of places where they had everything written out and it was in paragraph format and they addressed everything. And it wasn't in a grid or kind of a table layout like this. It was in paragraphs. And there was a couple of little tables in there about materials and whatnot, but it was a completely different format, completely legal. Clients liked it because it addressed everything and everything was written down and there was no way to get around it. One of the problems with welding procedures and PQRs also that people that aren't really initiated into the craft have problems with is that they'll end up thinking they have to fill in every blank on the WPS or PQR. You don't have to fill in every blank. You just need to look in the code and address certain variables, the essential and non-essential variables that need to be addressed depending on what you got going on. WPS, you have to address essential and non-essential, and a PQR, you just need to address the essential. You can address the non-essential variables on a PQR, but anyways, just because there's a blank there doesn't mean you have to put information in there, because it's probably going to get kicked back if the reviewer knows what he's doing. He's going to ask, why did you put this here? What does this mean? This doesn't have anything to do with what you're doing. So some procedures, some welding processes have variables that other processes don't. Shielding gas. Shielded metal arc does not have shielding gas. Gas tungsten arc welding does. So you have gas. Not as a shielded metal arc. If you're writing a shielded metal arc welding procedure, don't address shielding gas. So the advice or the rant for the welding procedure specification. Welding procedure specification. The welding procedure specification is a required document for all code welding. Your customer either directly or indirectly specifies to what code your company must qualify. The WPS outlines all of the parameters required to perform your welding operation. In short, the WPS is the recipe for welding operations. It describes the welding process or processes used, the base materials used, the joint design and geometry, gases, flow rates, welding position, and includes all of the process conditions and variables. Each code has a recommended format, but you don't have to follow the recommended format. If you want to come up with your own format, that is totally cool. You can run with that. But there are recommended formats, and it kind of gives you a good starting point. Recommended, not required. The procedure qualification record is the document that qualifies the welding procedure specification. This is a supporting document. In order to qualify your WPS, a procedure qualification plate is welded to the code requirements, the code you're using. The actual test parameters are recorded at the time of welding to ensure the WPS was being followed. So you have to record all of the essential variables when you are welding your test coupon or your test plate. And then you send the PQR off to the lab, and then they're going to do some bend tests, some tensile tests, some corrosion tests, whatever needs to be addressed, whatever physical tests need to be done. The lab is going to do them. They're going to send you back a stack of results for your mechanical testing, tensils, bends, whatever, and then you're going to take that and you're going to write a PQR. When you're done writing the PQR, you're going to write a WPS. That's how the system works. This is an ASME Section IX suggested format for procedure qualification record. You go through here, and for ASME Section IX, you address all the essential variables, and if you want to address non-essential variables, you can. You do not need to fill in every blank on here. If you fill in every blank, you're going to get yourself into trouble. If you don't do something, do not put NA. Like post-weld heat treatment, use the word none. If you did not use post-weld heat treatment, put none. Don't put NA. It is applicable, and you just didn't do it. None. None is better than NA. A lot of times when you're sending these in for review, somebody is going to look at it and say, he put NA, he should have put none. You need to put none. So don't fill in all the blanks. Make sure and address all the essential variables, and you shouldn't have too many problems. Once again, you don't have to use this format. It is recommended, suggested. You can use something else if you would like. This one works for a lot of people. Maybe it doesn't work for you. You don't like it. You don't like the colors. You don't like the lines, whatever. You can invent your own format and go with that. As long as you address all the essential variables, you are good to go. The PQR combines all of the information of the WPS and adds the test results to provide a complete document that certifies the welding specification. This document is also required by all codes unless you are qualifying under the American Welding Society specifications. Under certain conditions, the WPS may be considered pre-qualified, in which the PQR is not required. You can do this under special conditions, but you have to follow all of the rules to do it under the American Welding Society specifications, such as D11 structural steel. You have to use a certain type of filler metal, certain base metals are qualified, certain shielding gases at certain amps, volts, and travel speeds, and certain joint designs. You have to follow their recipe, and you do need to write it down. You can't just say, this is pre-qualified, I'm going to run with it. Does not work like that. You need to make sure that it is all written down and that you have addressed all the essential variables of that pre-qualification clause of the code. What goes on a PQR? What's the information that you need to provide in a procedure qualification record? Well, generally any supporting documentation, material specifications, electrode specifications, shielding gas specifications, all required testing, non-destructive testing, destructive testing. These tests typically include X-ray examinations, ultrasonic examinations, tensile testing, bend testing, and when required, impact testing. Might have chemical testing in there too, corrosion resistance. There's a lot of different things that you can have on here. But a PQR is you need to hit all the essential variables for whatever code you're working to, and then the required examinations. You're putting together a case, court of law type thing. You're putting together a document that is going to support your WPS. You can't have any holes in this. This needs to be tight. This needs to be airtight. So you need to include all that information, all the information that is required by your code or your customer specifications and requirements and documents. They all need to be in a PQR. The PQR supports the WPS. This one PQR can support one WPS. It's just a supporting document. Like we said, the WPS is a recipe or a work instruction for the welder. Yep, weld it with this many amps, this many volts, this travel speed using this filler metal and this shielding gas. Well, the PQR is the document that supports that, yep, we can deposit sound weld metal into a joint using these variables that are listed on our WPS. And here's our supporting documentation that said we did it once and we did a bunch of testing that proves that, yes, we can get the tensile strengths and we've got the required ductility and we don't have any problems and there's no defects in the weld. So one PQR can support one WPS. One PQR can support multiple WPSs. This is going to kind of get confusing, and I'm trying not to turn this into Abbott and Costello and who's on first, what's on second. But I worked at a place where we had multiple WPSs that were really, really close to being the same. But the only differences were there were editorial changes, or maybe there were small changes in the size of the filler metal. So let's say customer number one we're going to use WPS number one to make his component. Well, he only wants us to use 1/8 inch material, 1/8 inch 7018. Customer number two with WPS number two, he's like, I don't care. You can use 1/8 to 3/8. I don't really care. Do what you got to do. So have we changed anything? No. WPS number one just has tighter restrictions, but we haven't changed anything. The essential variables haven't changed. And then let's say WPS number three, he only wants he wants a change on how it's cleaned. He only wants a certain kind of wire brush that's shipped in from Kazakhstan or something like that. Something that is not an essential variable, but it's written in there. So that WPS is different than WPS 2 and WPS 1. But all the essential variables are still supported by PQR number 1. When we did PQR number 1, we didn't have a special Lithuanian or wire brushes sent in from Kazakhstan that were blessed by the Pope. We only had what we got off the shelf. Well, the customer on WPS number 3, he wants his special stuff. So the PQR number 1 can still support WPS number 3, but WPS number 3 is different from WPS number 2 and also different from WPS number 1, but they're all three supported because they're using the same essential variables. So I hope I didn't turn this into too much confusion, but That's how one PQR can support multiple WPSs. One WPS can require the support of multiple PQRs. You're asking, how can that be? Well, let's say I've got a whole library of PQRs, previous PQRs that I've done, and customer X wants a WPS written. He comes up and he says, Gary, I need a WPS so I can weld the root with flux core, the next pass with shielded metal arc, and the next pass I'm going to use, everything from there on out, I'm going to use submerged arc. And instead of going and qualifying a procedure that does all of those, maybe I've got procedures or procedure qualification records, WPSs laying around that contain all that data. So I go and find the appropriate PQRs, I gather them up, 1, 2, and 3. Yep, this one covers my gas tungsten, this one covers my shielded metal arc, and this one covers my submerged arc welding. So I put all 3 of those together, I write a WPS, I reference those 3 PQRs, and now I've got a WPS that is supported by 3 separate PQRs. And this can also pertain to post-weld heat treat or any number of essential variables. But a lot of times you'll look at a WPS and you're trying to do some work and not all the essential variables are addressed, so you have to go back and look at the other work and see what you can find. So that's how you can have multiple PQRs supporting one WPS. We're going to talk about the wall between procedures and personnel. Don't confuse the 2 sides of the wall. This is a Walt Spurko thing. Walt Spurko is the president of ASME Section IX and really intelligent individual in regards to welding codes. But this is how he describes it. There's a wall there. Personnel, the WPQ, is on one side of the wall, and then procedures, WPS and PQRs on the other. So you got to be careful and not get these things mixed up. A PQR has almost nothing to do with a WPQ, the Welder Performance Qualification Record, or a WPS. So you need to realize there's 2 separate sides to this welding universe, and don't cross-pollinate them or don't cross the streams. It's bad. So just make sure that you keep the procedures on one side, and when you're talking about procedures, you talk about procedures. And when you're dealing with personnel, you talk about personnel, and you just deal with personnel on that side. So the wall. Don't confuse the 2 sides of the wall. Welder qualification. The range of approval is not as restrictive for welder qualification as it is for procedure testing. Welder qualification has fewer essential variables than procedure qualification testing. One welder performance qualification can cover many WPSs. You're asking, how can this be? Shouldn't a welder have to qualify for each WPS? No, he does not. As long as he meets a certain number of essential variables, he's good to go on that. If I have WPS number 1, which is a WPS using gas tungsten arc welding with, let's call it carbon steel and 95% argon, 5% helium. WPS number 2 has stainless steel, let's call it ER309L with 100% argon. And then WPS number 3 has, let's call it another carbon steel with, I'm going to pick something strange here, argon with 10% helium. Under the rules for WPSs, every time I change the percentage of the shielding gas, I have to change the WPS. It's essential variable change. I have to change it. So when I went from WPS 1 to WPS 2 and I went from carbon steel to stainless steel, that's a change. That's a new WPS. And the same from going from WPS number 1 to WPS number 3. I changed my shielding gas. I've got to change everything. Well, the welder, he's just got to qualify on F6. So F6 is filler metal. And the filler metal is it's the form that the filler metal comes in. So whether it's carbon steel, stainless steel, they all fit under the F6 category. So he's qualified. Shielding gas, the welder doesn't have to, he can weld with any shielding gas with the gas tungsten arc welding process. Whatever the shielding gas is, he can use it. Every time you change a composition, you don't have to requalify your welder. Whereas with a WPS, every time you change it, you have to requalify a welder. So there's only a half a dozen or so essential variables for the welder to qualify to, but the WPSs have 20 or 30 that you really need to address, depending on which procedure, which process you're using, which welding process you're using. So you can have multiple WPSs that a welder can use, and he doesn't have to requalify for every WPS out there. He just needs to requalify for the ones where he doesn't have all the essential variables covered. Usually it's thickness, filler metal, and position are the three hang-ups where and backing. Can he weld open root or not open root? But there's 3 or 4 of them, and generally if you address those 3, 4, 5, 6 welder qualification essential variables, you're covered. And that's how a welder can weld with multiple WPSs. Summary. So we covered what a WPS was and what a PQR was and how they tie into, a general welding program, and how a PQR supports a WPS, and some of the general concepts involved in a WPS and a PQR. Hopefully I'll be able to put together a couple more presentations, and maybe we'll get into a little more depth in regards to how to write a WPS and a PQR and addressing essential and non-essential variables, and explain some of the nuances involved with those when writing a WPS and PQR. Hopefully this gave you a little more insight into how welding programs work with a PQR supporting a WPS, and why we qualify weld procedures and procedure qualification records. Here's my contact information. If you got questions, want to bounce something off me in regards to, hey, how do I do this? What's going on? WPS, PQRs. I also do welding consulting. But anyways, if you have questions in regards to WPSs and PQRs, don't be afraid to lob me an email, and